Thank you. I was supposed to give a talk with my colleague, Vova. Unfortunately, Vova couldn't make it, so let's start with a video message from him.
Good morning, RailsConf. The last day of the last RailsConf. I don't want to say ever. I hope just for now. But anyway, it's a good time to talk about the future. The wise man said, education is the passport to the future, for tomorrow belongs to those who prepared for it today. What does it mean to be prepared for framework? It means making onboarding new members as easy as possible, as smooth as possible. So new engineers can start using the tools to build products they want to build as quickly as possible. And that also means that learning Rails, we're talking about Rails, right, should not be a blocker. Let's imagine I'm a person who wants to learn Rails today. What am I going to do? Well, I will probably open my browser and search engine and start typing learn Rails. Oh, wait, it's 2025. Search engines? No, we don't use them anymore. We use AI tools. You know, we don't want to think and figure out which search results are good or not. Let's just delegate that to some statistical or whatever it is. Okay, I want to learn Rails. And it says guides Ruby on Rails, getting started. Okay, let's take a look at that. And what we have here: introduction, philosophy, creating a Rails app, prerequisites. So for this project, you will need Ruby, free to whatever, Rails, code editor. Wait, install Ruby on Rails guide. Okay. Oh, depending on operational system. Well, I'm a Mac. What is that? What does it even mean? Open SSL add free. I don't even know what it means. So let's rewind. Morning RailsConf. Imagine that the answer to the question we asked would be not the getting started static documentation guide, which is good, it's perfect, but it has a blocker of needing to deal with all the dependencies, figuring out operational system stuff, code editors, and whatever else we need for that, right? So what if we just had a link to this resource? Interactive in browser getting started Rails tutorial. It looks exactly like a getting started guide, but we can click through, read about philosophy, and get started by creating a new app. Wow, Rails version. That's just cool. And so on and so forth, up to the very end. Alright, we just finished the whole Rails tutorial without leaving our browser, and this is not a fiction. This is reality. This is not the future. It is today. And the Rails tutorial, in-browser Rails tutorial, will go public right after this talk. The talk in which we would like to share not only the technical details and challenges of building this experience, but also some thoughts on how that could change the way we think about Rails, the way we bring new people to Rails, the way we build with Rails in the future. My name is Vladimir. I've been with RailsConf for 7 years already, and I'm not the future. I'm actually more like a past. So I want to give the stage to my colleague, Albert. It's his first RailsConf, and I hope not last again, to tell you everything about how we built this and what we want to build on top of that. So say hello to Albert and have a great conference.
Hi everyone, I'm Albert. Let me begin my part with a quick introduction. My professional journey started right here in this community For years, I've been a Ruby on Rails developer, just like many of you in this room. And this community made me who I am today. I really want this community to thrive. And I think that this little blocker of getting started with Rails is actually a huge deal. Because statistically, there's probably so many brilliant people, brilliant engineers who at some point were interested in Ruby on Rails, but didn't become a part of this community just because during their onboarding they stumbled upon some failed native extension build or whatever. Making the initial experience frictionless is very important. And we decided to re-implement the whole Ruby on Rails tutorial for that. I'm really happy that I got a chance to become a part of this project. For me, this is not just about solving a cool technical challenge, which it also is. But first of all, it's something that has the potential to affect the whole community. Before I jump into the technical part, let me share a bit more information about myself relevant to this talk. I've joined Evil Martians in 2023. At Evil Martians, we consult startups. That's what we do. And after years of experience working in a strict corporate environment, diving into chaotic energy of startups was a massive paradigm shift for me. And this career change actually brought me much closer to the open source world and to Ruby community. For the last year, I was a part of our team at StackBlitz. These photos are from their offsite in San Francisco, where I had an opportunity to meet the guys in person. It happened just a few months ago. So, what is StackBlitz? StackBlitz is a fully featured in-browser IDE that provides zero setup development experience. You can just import any repository and without a tedious setup, get a live interactive preview for any kind of JavaScript application. You've probably heard about StackBlitz for the first time right now, but I'm pretty sure, I think there's a high chance that you're aware of their recent AI product, Bolt. Bolt is an AI coding agent, and there are quite a lot of AI coding agents nowadays. But what makes this one special is that the entire user experience runs completely inside the browser. And that's because it's actually powered by StackBlitz. So we, Evil Martians, help StackBlitz to build amazing products. And Evil Martians love Ruby and Rails. It was quite natural that at some point we've started asking ourselves questions. Can we bring the same zero setup experience from JavaScript world to Ruby? And if we do, who will benefit from it the most? Answering the second question led us here to the Rails tutorial. And we will dig into that just in a second. The first question, however, took us some time to answer. And the answer is yes. We started with putting a production Rails application to the browser about a year ago. And it's kind of solved the problem. We've already talked about that. You can check out this blog post, for example. It was already a huge success. But running a Rails app in the browser is not the same as implementing the development experience. Now let's move to the main part of the talk, in which we reveal the key ideas and challenges powering our tutorial. OK, are you ready, kids? Let's start from the bottom. I guess today is the day of the SpongeBob references. Of course, the first key ingredient here is WebAssembly. This is something that is designed as a compilation target for high-level languages. You take a program, or in our case, we have to take the whole Ruby interpreter, pass it through the compiler, and we get a nice WebAssembly binary, which we can run in any WASM runtime. This can either be the web browser or some standalone runtime on the server. By default, WebAssembly runs in a very strict security sandbox. This means it doesn't have any access to host resources, like the file system or networking. And for us, of course, this is kind of a deal breaker. So how do we solve this? The answer is WASI, or WebAssembly System Interface. A WebAssembly module compiled with WASI can import and call specific system-level functions, like, for example, reading or writing to disk. The key here is that these functions are not implemented inside the WebAssembly module itself. Instead, the implementations are provided by the WASI-compatible runtime. The next ingredient in our Rails on WASM pizza is the Ruby WASM project. This project packages everything needed to run Ruby in a WebAssembly environment. It handles three main things. First, it distributes Ruby runtimes, precompiled to WebAssembly WASI modules. Nowadays, starting from Ruby 3.2, these are official builds on the interpreter. Second, it provides a gem packaging toolchain, which lets us bundle the Ruby interpreter together with any gems that our app needs, and even some gems with C extensions are supported. And finally, it patches or disables Ruby features that are incompatible with WebAssembly runtime, such as, for example, threads or native sockets. So we have Ruby running in the browser, thanks to Ruby WASM. That was pretty simple. What about the framework itself? That brings us to the final ingredient, a tool we built called Wasmify Rails. This is something like a glue that takes Rails application and packages it into the WebAssembly environment. It uses Ruby WASM toolchain to build a binary that includes all of Rails project files. And most importantly, it generates necessary configuration and adds shims, or patches, to the framework to ensure the app boots and works correctly in WebAssembly environment. So far, we've covered the main ingredients needed to run Rails in the browser. If you want to learn about it more, I highly recommend checking out this guide written by Vova, my virtual co-speaker. And a fun fact about this guide is that the website itself is a Rails application running on WebAssembly. So at this point, we have our packaged Rails app. Now it's time to make it functional. For this, we are still missing a couple important pieces. Let's circle back to our demo for a bit. Well, if you think about one of the first lessons in our tutorial, it's starting a Rails server. To make that happen, we obviously need a way to spin up an HTTP server in a browser. Also, obviously, we need a real database that can run entirely inside the browser. That gives us our final missing pieces, the web server and database. Let's begin with database, because it's actually pretty simple. There are a couple of great open source options available today. SQLite WASM and pglite, both are fully functioning database engines compiled into a WebAssembly module. And our Wasmify Rails gem actually implements the adapters for both. But for our demo, we had chosen pglite. The main reason for that is the fact that it's designed to work exactly the same in a browser and Node.js environments, which means that for pglite, we won't need to implement the separate adapters for Node. Wait a minute, Node.js wasn't the plan to run everything in the browser, including the database? To answer that question, we need to take a look at one more technology that is used in our demo. Let me introduce you the web containers. This is the core technology that powers everything at StackBlitz, meaning all their products that implement interactive dev environments. The simplest way to understand it is something like a mini operating system that runs entirely inside a single browser tab. Let's do a quick overview of the web containers architecture. First, the entire runtime boots up inside a web worker. This is the key because it runs on a separate thread, completely isolated from the main application UI. So the page stays fast and responsive. Inside the runtime, we have our Node.js runtime, which is the JavaScript V8 engine itself compiled to WebAssembly module. We also have a virtual file system, which lives entirely in the browser memory with no direct access to disk. And finally, for the networking, all HTTP traffic is intercepted by a service worker. It acts as a network proxy, routing requests and making localhost magically work inside the browser. This is why when the Rails server is running on port 3000 in our demo, if you check which ports are occupied on your local machine, you won't see anything running on the port 3000 because Web Container has its own isolated local network. And finally, once the server is ready, its URL is mounted into a preview iframe from your web page, so you can see and interact with your live application. OK, so now we can put all the pieces together. By running everything inside the web container, we get an access to its Node.js environment, which we can use to spin up an HTTP server, our last remaining piece of the puzzle. Next, I'll show you a couple interesting technical challenges of integrating with web containers which we faced. The first challenge is called the bridge. Web container runs Express.js server, which means that we have to somehow bridge it together with our Rails server. So let's see how we implemented that bridge. And by the way, if you like thrillers, this is a great TV show I highly recommend. We have implemented this by defining a custom backup handler, where during server initialization, we define a global request handler referred to the incoming handler variable, which we then call from Node for each incoming request. Let's take a look at this handler's implementation. It basically receives the request from Node.js, translates it to the rack-compatible format, and then it fetches the response from Rails, and finally passing it back to Node.js. Let's quickly walk through the life cycle of the HTTP request to get another perspective. First, Express.js server receives the request. Then we save the request data to the JS global scope, which we'll be able to access from Ruby through a special API. Then we trigger the execution of Ruby code with our global request handler call. Then on the Rails side, we fetch the Express.js request data from the JS global scope, convert the request data to the rack-compatible format, and once we got the rack response from Rails, we convert it back to the Express.js compatible format and passing it back to Node, where we unpack the data from rack response and finally send the response to the client. Pretty simple stuff. The next challenge is called the console. Of course, I'm referring to Rails console. How did we implement it? I'm sorry for this one. I just have this wall of code for you, but it's actually pretty simple. Bear with me. Here, we basically took the advantage of having full Node.js runtime. The class you're seeing decorates a REPL from Node standard library. In the start method, which loads the console, we initialize Ruby IRB in the global IRB variable, which we are using during specific commands evaluations in the eval method. There's also a project that implements true IRB as a WASM module. It's called irb.wasm, and we're currently looking into this one and planning to integrate it in the future. To the next challenge. In the previous ones, we implemented running the server and the console, but how did we implement running those commands in Node environment? Let's take a look. In Rails, we basically have two kinds of commands. First, we have one-shot commands, which we just run, and they produce some output, and that's it. And the second kind of interactive commands is the commands which start some long-running process or session that you connect to. For one-shot commands, the solution is simple. We can just simply delegate them to Rails. While for interactive commands, it's not so obvious. Just delegating them wouldn't work. So what do? We treat these kind of commands as an external ones and do a special handling for them. For server command, we just start our rack-compatible web server. And for the console command, we initialize our Node-powered IRB implementation. The actual logic for both methods here is basically just calling the solutions we solved in our previous two challenges. Of course, there have been more challenges in our way, but unfortunately, I cannot cover them all. So let's move to the next part. Now we figured out how to run Rails inside the web container. And let's circle back to our original goal, the interactive Rails tutorial. So what about the actual user interface? Do we have to build all the front end from scratch? And we actually could. The web container provides a powerful API that allows us to interact with it, but luckily, Stackbase come to the rescue with Tutorial Kit. Tutorial Kit is an open source framework designed specifically for building interactive tutorials. Just like the one you're seeing right now, and just like the one we built, because our demo is actually based on it. Of course, since it's a Stackbase product, Tutorial Kit is powered by web containers, which means that we can simply integrate our entire Rails on Wasm setup with it. OK, so let's take a step back and look at how all of the pieces fit together from a slightly different perspective. At the very core, we have our Rails Wasm bundle. This is what we built with Wasmify Rails. Alongside it, we have our essential services, the PGLite database engine and rack-compatible web server, which acts as a bridge to the runtime. The entire application stack lives inside the web container runtime. And the user-facing layer is the Tutorial Kit UI. It provides the lesson content and orchestrates the entire experience. And finally, in the Tutorial Kit UI, there's the two main interactive elements, the live terminal and the preview iframe that displays our running Rails application. So the future is here. This is how a demo works under the hood. And the demo is live. You can try it out right now. Just be aware that the interactive part might not work on the mobile devices. So now let's talk about what's next for us, where we are planning to go with this project. Our next main goal is to provide a generic tool which would allow gem maintainers to build any kind of interactive tutorials. And I think this is very exciting. Just imagine being able to run some code or commands while reading through your favorite gems documentation. I'll be speaking at EuroConf in Portugal this September, and my talk will be dedicated to our progress on this. So if you want to see the next chapter of this story, please join me there. And one amazing outcome of this project is that we were also able to run Rails in Bolt. Check it out. How is that possible, you may ask? Well, remember all of the work to get Rails running was done on top of the platform. We never had to change the core web container runtime. And because our solution is completely self-contained, it means that Rails can now be run in any product built on top of the web container platform. And this, of course, includes Bolt. So one of the artifacts of this tutorial is a Stackbase-ready Rails template. You can play with it today. Just import this repo in Stackbase or Bolt, and you can see how it magically runs Rails. Actually, not magically. You've just seen how it works. We have to ask ourselves a question, though. Is bringing Rails to Bolt even worth it? Well, I personally think that it has a lot of potential, both in Bolt and in any kind of AI agents. And the key reason for that is the maturity and depth of the Rails ecosystem. We all know that AI agents can be pretty unpredictable, so the key metric for their success is generating less code. And because of the eloquence of Ruby and the convention over configuration principle of Rails, most of the time it naturally requires very few lines of code for the same tasks. We hope to share more exciting news about the Rails in the browser, and maybe even about Rails in the Bolt later this year at our new SF Ruby conference. So please, come join us. And let me end this talk with a few final words. The theme of the conference is the future of Rails. In the beginning, Vova said that the future is not him. And I actually agree. The future isn't him. And the future isn't me either. The real future is the newcomers. It's all the people who are about to take their very first step into this community. And this future will become our present. So I'm inviting you all to build it together. Thank you.